Yeah, my name is Melissa Furukawa from Peel Passive House Consulting. We're actually based in Canada. I'm an accredited Passive House certifier, also trainer, CPHD, and component certifier. And yeah, but today my presentation is going to be about what are the actual hoops to meet Passive House certification. So I'm going to go over the kind of main criteria for Passive House, as well as kind of sprinkling some tips and tricks in there, and then go over the general process for certification. And then also sprinkle in the end some more tips. Yeah, happy to take questions throughout the presentation. Sometimes I find that's helpful because you may forget it by the end of it, but we'll also have a little bit of time at the end too, in case there's other questions that you think of. Oops. Okay, so just a short bit about PO Passive House Consulting. We do everything Passive House. So we do Passive House Consulting, also building certification, component certification, mainly window frames. We're also involved in some Passive House research. Right now we're doing a research project on cold air distribution. So that's kind of an innovative HVAC system that uses one heat pump to heat, cool, and supply domestic hot water for the building. And then we also do some training. Yeah. Okay, so now kind of just jump into the overview of the criteria. So ultimately, everything comes from the Passive House Institute. They certify people, so that can be Passive House, like a designer, consultant, tradesperson, also building certifier. And now there's like so many additional seals, PHP expert, construction verifier, site supervisor. I can't even keep up with all the additional seals. They also certify components, so windows, ventilation systems, um, building like building assemblies, cladding systems or clips, and what we're going to be focusing on today, which is buildings. Um, there are basically 5 building standards right now. I mean, of course, we started off with the classic passive house, and then they expanded it to have kind of classic plus and premium. So plus and premium acknowledges like when you have a certain amount of renewable energy, so like solar panels on your building, for example. We also now have the Anafrit standard, which is for retrofit buildings, and the PHI low energy building. And this was really created to um, yeah, just kind of have a certification for those buildings that can't quite meet the passive house standard for whatever reason. Maybe it's a very small building, maybe the site orientation is just not ideal, maybe there's a lot of shading. So it has like slightly more relaxed targets than the kind of classic house standard. So it's a great option if you have other kind of constraints on your project and you can't quite be passive house, but still kind of getting some kind of recognition for all of the effort because passive house is, like really great. But a lot of buildings, there's still like great buildings. There's still, really sustainable and high performance buildings, but just can't quite meet the classic passive house standard. Yeah, of course, this is the link to download the kind of full criteria. Um, Yeah. So each criteria basically has a specific table like this that shows kind of basic criteria in terms of spacing and demand. So this is for the Passive House Classic spacing and demand. Sorry, and most of my presentation is in metric because I'm in Canada. Um, but it's 15 kilowatt hours per meter squared per year, or a heating load of 10 watts per meter squared, cooling demand, which also kind of depends on your project, but it's around 15 as well. And then air tightness of 0.6 air changes per hour at 50 pascals. And then, of course, we also have our primary renewable energy PER demand, for classic plus and premium, and then a renewable energy generation requirement if you're going that plus or premium route. And then there's a similar table like this for low energy building for Enefit, which I won't go into today, but also just as an aside, EnerFit also has kind of two pathways for certification. One is an energy demand kind of regular way, and then the other one is component. So there's like you have to meet certain like a certain R value for your walls, a certain R certain heat recovery efficiency for your ventilation unit, that kind of thing. So it's more prescriptive, whereas normally Passive House is very it's not prescriptive, it's holistic, and you kind of consider the whole building design to meet your targets. Okay, so now I'm just going to kind of dive in a little bit into the general criteria for all the standards. Yeah, the first one being frequency of overheating. So if you don't have active cooling, like mechanical cooling, which is possible in a passive house depending on your climate, you can show basically you either have a requirement for the space cooling demand or the frequency of overheating or excessive humidity. So without mechanical cooling, it has to be less than 10% of the time overheating, which is actually like a lot of like if you think about 10% of the year, like that's quite a lot. So this is the maximum, the kind of guidelines. I would, typically try to aim for less than 5%. And actually now I'm in like just outside of Toronto. We used to have projects without mechanical cooling, and it could be possible with like passive cooling measures like shading and that kind of thing. Um, but now we don't do it because we know our climate is changing, and it's better to, future-proof your building to have the mechanical cooling at least, kind of thought of plumbed in so that it's easy to kind of insert later or just have it already integrated. Yes, yes, and then there's also a requirement for excessively high humidity. Um, yes, and just some kind of tips about if you're going for no mechanical cooling, and you're relying on things like shading, people opening the windows, like, are they realistic? Is your occupant going to open their windows for 8 hours a day? Are they going to open them at nighttime to get that night cooling? If your building is like in a busy downtown area, like, does it make sense? Are people really going to leave their bedroom doors open night when there's like a train nearby or traffic or so you have to really think about like, are the assumptions that you're putting into the PHP realistic? And also it's good to stress test the design. So like how much overheating would you get if people weren't opening their buildings, if you had zero natural ventilation, if they didn't like use their blinds, if um they left and like put their HRV or ERV on away mode, so a lower ventilation rate. Um, yes, as a certifier, we also kind of do these kind of stress tests, but it's best to kind of also on your own part while you're like working through the design to test these things. Ventilation. So yeah, we had to provide mechanical ventilation to all rooms. There should be user control. The relative humidity should be, like in the wintertime, above 30%. And there's also recommendations for the sound level. The sound level, I mean, you don't have to kind of go around and prove that the sound is not, but if there's anything in the design that the certifier kind of flags as this may be an issue, or if something comes out on site, then should be addressed. So just thinking about like where you place the ERV, using things like silencers, and also to make sure there's no uncomfortable drop drops. So we don't want like a bunch of cool air kind of directly hitting somebody. Okay, so for controllability, for residential, single family homes or multifamily, there should be individual suite control. Usually it's kind of standard rate, boost rate, and then an away rate. Um, in some areas, we find that the code requires a lot more ventilation than we typically require for passive house. And if that's the case, then you don't have to have like all these different speeds. You can just have a constant speed because it's way higher than what we would require for passive house anyways. Non-res buildings, so like an office or a school, or there's no specific requirements for like having controls, but it is highly recommended to have demand control ventilation, and also like if it's like an office or a school that's not used overnight, then it makes sense to shut it off. And you can kind of test in the PHPP, like what is the impact if I'm not running the ventilation unit, for 8-10 hours overnight, and you can see the impact on the spacing and demand, on the space cooling demand. You would want to have a kind of 1 hour flush of the building before occupancy. So just to kind of remove any contaminants in the building before people arrive. Um, and yes, like I said about acoustics, yeah, you just kind of certified flagging if there's any concerns about high noise. Passive houses in general are very quiet. So if there is like noise from the ventilation system, like the ducting or the ERV, then it's like more obvious. Yeah, relative humidity. This can especially be an issue for colder climates in North America. Sometimes, just using an ERV is sufficient. Making sure you're not, yeah, so having moisture recovery and an ERV. You could also, if you need kind of more than that, have humidifiers or demand um, control ventilation, so that you're not over ventilating. Um, And yeah, if it's kind of flagged as an issue, you can kind of also have, there's various monitoring options to implement subsequent measures. Um, yeah, sorry. The next kind of category is minimum thermal protection. So this is an interior surface temperature. So the difference between like a surface temperature and kind of the room temperature has to be less than 4.2 Kelvin. Um, Generally, like this is easy to meet in a passive house. It's more so around like windows and doors um, installs. And then also there's a requirement for floor temperatures, and this is generally not an issue except for maybe in retrofits where if you can't insulate underneath the slab and you're in a cold climate. Um, Yes, so yes, this is just talking about the comfort criteria for windows and doors. So yeah, generally in North America, we need like very high performance windows and glazing, triple glazing. I often say like if you're going to use Passive House certified products on your projects, like number one, the ERV or the HRV, because it's hard to get the right data that you need for modeling in PHP. And then second is the window frames. Um, yeah, and so using high performance Pascal certified window frames, having really good install details, um, and then yeah, we'll talk about how if it's you're not quite meeting the comfort criteria, then you can also have supplementary heating near the window and door to kind of account for that.
Hey,
Yeah, and don't
Melissa,
just yeah,
can I interject a question here?
yeah, yeah.
Did you say it was hard to get data from like relevant data for PHPP from PHPP for something around the modeling around the doors? Is that what you said, or did I mishear
Oh, I
that?
said it's best to use certified window frames. Um, yeah. Number one, use a certified ERV or HRV, and then number two, use certified window frames. Because it can be hard to, especially like in North America, are like it's not the data that's kind of readily available isn't readily kind of you can't just like plug and play it into PHP because we need like all these like specific things like the size value of the spacer and the U value of the frame separate from the glazing and yeah,
So you're saying don't like cut it close, get a really good window is kind of like the takeaway. Is that what
yeah,
you're?
yeah,
Yeah.
yeah,
Okay.
exactly. Yeah.
Thank you.
Mhm. And yeah, don't just assume that your psi value is 0.0. Sorry, again, this is a metric, but in the PHP, there's kind of a default value, right? For the psi value install. In metric, it's 0.04 watts per meter Kelvin. Don't just assume that your install is that. That is still like a fairly good um install. So if you're not sure, consult with your certifier. Look at if you're using a certified frame, which you should look at the certificate, look at their installs and their psi values and compare like, okay, is my install pretty comparable? Do
Mhm.
I also have over insulation? Is my frame also kind of in the middle of the wall assembly? Um, yeah, and also note that door installs, especially the thresholds, are often even worse than this because yeah, it's just not possible to kind of over insulate and these kinds of things. Yes, and window, especially doors, like they're not as long, but you only usually have a few doors in your project, but windows are the longest thermal bridge in your model, and so it does have a pretty big impact. So if you're going to kind of yeah, fine tune slash model one of your thermal bridges, like that would be the key one to kind of pay attention to. Um, yeah, and this is just an example of a building in Southern Ontario. They have assumed a psi value of 0.04, which again is that default value. And you can see in the PHP, all of these windows are flagged as not meeting the comfort criteria. But like we're still meeting the the spacing demand. The spacing demand is fine. But yeah, those surface temperatures on those windows are too low. Now if we like take that same building but change the sign until install to 0.02, so we've kind of cut it in half. Well, now we still have one window that's not quite meeting the comfort criteria. Um, so just by like improving the install, we can eliminate the amount of windows that are not meeting the comfort criteria. And maybe for that one, maybe we have some kind of supplementary heating near there. If we
Mm.
have supplier cooling or supplier heating, maybe we're directing it towards the window, or maybe we have some kind of little electrical heat source near there. Yes, this is about condensation risk. So another kind of check that we do is the FRSI. So the FRSI is this equation here, which is the minimum temperature on a surface minus the ambient temperature, so outside temperature divided by the inside temperature minus the outside temperature. And so this is a ratio. It goes from 0 to 1, theoretically. Um, yeah, and there's different requirements based on what your climate zone is. So the higher the FRSI is the kind of better. And yeah, this is just kind of an indicator like if you have a really low surface temperature on like for example a junction between your floor and your wall, then you calculate this FRSI factor and it kind of guides you if there's going to be risk of condensation and mold growth there if it's below a certain value. So most important things to check are especially like window installs. So this window, the minimum temperature is 14.3. It's usually around like where the window meets the wall. So then you can calculate the FRSI and it's 0.81, which is quite good. Um, yeah, no, would be the same answer in Fahrenheit because we're just doing a kind of ratio here. Um, oops. Yeah. Yeah. So if you have like so for you gotta make pay attention to your window installs. That's a kind of critical point. But also if you have any places in your building where you have a high psi value, then you should probably check your FRSI too, because there's if you have a high psi value, then that means you have a high amount of thermal bridging, which means you could have a really cold spot there. Um, Exceptions to this are if you have a really small, or oh, sorry, for the comfort criteria, if you have a really small window, like less than 1 meter squared, then it's kind of exempt from the comfort criteria. Um, or if you have a window or door in a kind of non-living space, like if people aren't going to be, this is all about like how the occupant feels, right? So if we're really close to a cold window, then we're going to have a radiative loss from us to the window and we're going to feel cold. But if it's in a space like a storage room or even like the like an entryway where like people don't hang out there, then it's not really a concern for comfort. So it can be exempt. Also in the new for in terms of the temperature, the FRSI, in the new PHP, so it used to be that the FRSI was related to what climate zone you're in, and it was kind of a fixed value. And now, in the background, PHP 10 calculates a project-specific FRSI, and it takes into consideration internal humidity sources, the moisture recovery from your ERV, how much ventilation air change you have, because that all affects how much moisture is inside the air in the building. And so that affects if there's going to be condensation or not on a surface. Um, yes, and there's also a separate temperature factor for door thresholds as well. Um, yes, and like I mentioned before, if you can't meet either the comfort criteria or the FRSI factor, you can also just employ like a heater nearby to make sure that surface temperature doesn't get too cold. These are just some examples of some heating. Occupant satisfaction. I think this is all pretty general. Like you have to have a window, operable window in each room, which is generally normally required anyways. Operable lighting and temporary shading, and the ability to regulate the indoor interior temperature. I don't want to, I think I need to go into that anymore. Okay, now I'm going to go over the general process for Passive House certification. Okay, so sorry. So we have the kind of project team. This is like the architects, the engineers, developers, owners, and builders. And they kind of feed all of the information about the project to the Passive House certified Passive House consultant or designer. And so that person can be like a separate individual from the team. It can also, oftentimes it's also like the architect or it's also the mechanical engineer. Um, yeah, so that's also a possibility. But basically, that person kind of gets all of the architectural drawings, all of the HVAC drawings, all the specifications, and uses all that information to create the model and make sure that also the design is meeting the criteria. Um, yeah, designer, consultant, honestly, it's like all the same. Um, and then that person feeds all that information to the accredited building certifier. So that could also be PHI, but like the Pass House Institute also certifies buildings. But now they've kind of created these accredited building certifiers because Pass is growing and there's so many projects they can't possibly handle all of them. And also sometimes it's nice to work with a local person, even if just even being in the same time zone, right, is helpful. Um, yeah, so you appoint, and that person has to be kind of third party, so they can't be involved in the project in any other way. Um, and they kind of communicate back and forth mainly with the as well as consultant or designer, and then the designer should be kind of communicating back and forth with the project team. And then ultimately, the certificate comes from PHI, the Past House Institute. The certifier, the accreditability certifier would submit everything to PHI. PHI will provide the certificate and the plaque, and then um, give it back to the team. So there are basically four main stages for the certification. The first one, which often gets missed and overlooked, but has a lot of value, is the pre-submission guidance. It's similar to just like ad hoc consulting. Could include like PHP reviews or design PH reviews, just answering questions about the project. I'll kind of get more into this, I think, in the next slide. The main kind of bulk of the work of the certifier is the, doing the design stage review. So this is a comprehensive review of all the drawings, all of the details, products that are being used, the PHP, any thermal bridge modeling. Um, then depending on the project, there could also be stuff to do during the construction stage. Often this varies be between certifiers and also projects. Often we certify projects that we are nowhere near, like we certify projects all over Canada and also in the US. And so it's not always like, it doesn't always make sense for us to kind of go um, to site. And often most of our work can be done just through email or phone calls. So typically, like for us, unless we are physically close to the project, usually we're just giving advice to the consultant. Yeah, they may say like, hey, like there's a construction change and they want to use this project instead of this project, like, is that okay? What is the impacts? That kind of thing. Yeah, so just kind of giving ad hoc advice. And then the kind of second main work is the post-construction assessment. And this is kind of after the building is complete, reviewing the air tightness testing results, reviewing the ventilation commissioning report, and all the photo documentation for the construction.
I have a question.
Mhm.
Let me my video, sorry.
Yeah.
Um, so could you go back one slide?
Mhm.
At what point here should there be like some obvious red flags if something's going wrong?
Mm.
Hmm. Um, That's why, and I'll talk about this, that's why we like to do the pre-submission guidance because like you don't know what you don't know, right? And sometimes like especially if somebody has been working on a lot of like single family homes and this is their first like multifamily or non-res building project, yeah, like PHP can be it's complicated, right? And so yeah, that's why we often say to people, it's best to get your certifier on board like at the start of the project so that if you have any questions about, you know, anything like how to model a certain thing or like, is this a thermal bridge? Like, what's a reasonable conservative estimate for this? That can be addressed. Yeah, but I would say, yeah, usually in pre-submission. Um, but then you have to know the question to ask, which is not always the case.
Mm.
So then the second one would be during the design stage review. Yeah,
Awesome. Thank you.
yeah. And
Melissa,
for yeah.
I have a question too.
Mhm.
So if you're not being on site, like who does
Mhm.
the blower door test, for example, or do you have to go on site
Yeah,
for the final
no.
post-construction assessment?
Yeah, so the blower door test has to be done by like a third party person too. Like it also can't even be the certifier. Yeah, so it has to be a third party. And sometimes we consult on how to do the blower door test because like for a single family house that's pretty straightforward. But if you have, you know, a high rise apartment building, for example, and things are being built in stages, we often say like you should do a kind of mid-construction test when everything is
Mhm.
still visible. You can still repair things. You can still do a leakage search. You can still fix things. And then when the building's done, you do a final one. But sometimes in these larger projects, they're building floor by floor and things will get covered up. So sometimes we consult on how you can do a kind of guarded test where you have a little maybe like a little mock-up room, maybe it's like the corner room, and you kind of guard it all off and like just test that room to make sure that at least you're kind of or you do the whole floor, but you kind of assuming that like the work is consistent, but at least if
Mhm.
there is any major issues in the way that they're installing the windows or something like that, it can be flagged.
Hmm.
Yeah, so we might consult on like how to properly do it for some of these like larger buildings, but it has to be kind of also done by everything has to be like third party, like I don't have any vested interest in this. Yeah.
And so the blower door person, are they certified in any manner, or they just have, like,
No, yeah, they don't, yeah, I don't think there's any certification for that. We do, yeah, there are certain, like there's a certain procedure, I guess, to,
yeah.
what can be sealed, what shouldn't be sealed, that kind of thing. You have to do like so many different, you have to do a negative pressure test and a
Mm,
positive pressure test, and you need a certain amount of points. It's like five on both sides. Anyway, so there is like some guidance on like how to do it, and
mm.
what to kind of document. But yeah, no kind of certification requirement. Mhm.
Thank you.
Yeah. Yeah. And yeah, I guess because we don't go on site, like we're really reliant on like good photo documentation. So not just like taking photos of the assembly, but like having a like a measuring sorry, measuring tape, and like showing like yes, this is actually like whatever 8 inches of insulation. Um And then also at the end of the day, we have the kind of declaration from the contractor to say, like they're kind of taking responsibility, like, yes, everything was built as designed. Um, right, so just kind of diving a little bit more into detail into all those points. So the pre-submission guidance, yeah, like I said, this is where the certifier really adds value because the certifier has seen a lot of projects, right? They've seen a lot of different projects. They've had like they have their own lessons learned from their own projects, but also other people's lessons learned from other projects. So they can, they might have seen a similar detail and they know, oh yes, like we can use this psi value because this is a similar detail, or they had a similar, I don't know, issue or something that they resolved on another project that can be applied here. They may be, some cost-effective ideas for like either building assemblies or like the components that you're using. Yeah, they can flag things that have failed on other projects or yeah. And yeah, yeah, it's mainly like flagging things and sharing shortcuts, right? Solutions that they've already worked through on another project. And I think that's the one thing that I love about this like Pass House community. It's all about sharing, right? Our experience and not everybody doesn't have to start from scratch. Yeah, and so this is where the certifier can really save you time, money, and headaches. But yeah, you also have to know the kind of questions to ask. And I think just really just having the mindset that there's no dumb questions. If you're unsure of something, like that's what they're there for. That's their role on the project. And even if you have a preliminary PHP, just having them have a kind of quick sense check on it is also something that could be done. Um, yeah, this is just sort of the point. The irony is that newbies often avoid early guidance because they don't think they need it, but experienced teams like rely heavily on it, and then they know the value of it, and even experienced even when we're consultants and we have somebody else certifying, like we also every project is different. Every project, especially like we tend to work on these like first of its kind projects, like there's always questions that we're asking because we also have direct access to PHI. We're always asking PHI questions. We're always asking our certifier questions. So there's no like PHI is always continuing. Sorry, Pacifos is always continuing to grow into new building types, new climate zones. So you know you never have all of the answers. Yeah, and so the second part is the design stage review. Like I said, that's the bulk of the work. This is where we identify any issues that could put the project at risk for not meeting certification. And so yeah, it's a kind of fine balance. We recommend it taking place before everything is fixed, like before the windows, the insulation, the HVAC systems are fixed. But you still have to have some kind of sense of what they are, um, so that if there's changes that need to be made, they can still be made. Um, failure to submit a formal design stage review package is the number one reason why pass projects do not certify. We have so many projects who come to us actually like after construction. So there's like no way, or they've already started construction, and then it's really hard to, when something's on paper, it's really easy to just be like, oh, we'll just change it there. And something's already built. Um, yeah, you're adding complexities. So yeah, don't do that. Do your design stage review, make sure somebody's vetting that the design is good, and then continue with your um yeah, and then also for larger projects, we tend to do multiple design stage reviews. One kind of I think, yeah, depending on the size, it could be like three. One during like schematic design, one during DD, and then one during construction drawings. And that's way, yeah, again, like it's about flagging things before they're kind of set in stone and before the design has gone too far down the line that it's harder to change and adjust things.
So if a team does make that unfortunate
Mhm.
mistake, choice slash mistake, is that where people end up in the PHI low energy building category? Is that like typically how
Um,
you end up there? Or you know what I mean?
Sometimes,
Is
yeah.
that like a bronze medal? You know, how would you describe that?
Yeah.
Yeah.
Sometimes, and I mean, it's great that we have that now because we also always use that as a kind of backfall. Like usually, if you
Yeah.
can't quite meet pass, like you will meet because it has been somewhat designed to passive house. But also there's just some buildings that are oftentimes maybe there's like a conflict between the client's other requirements. Like maybe there's a beautiful view, but it's like to the north, but but that's important to them,
Hmm.
right? So they're not going to compromise that to meet the passive house or um yeah, like site orientation, like maybe the layout of the building is, yeah, just not as compact or so, or it's like just hard, like a hard climate, like a cold climate. So yeah, sometimes it's just even if you've done all of the work kind of ahead of time and you have a certifier and sometimes there's other kind of competing interests.
Hmm. Hmm.
Yeah. Yeah. Um, yeah, so this is the kind of general map of how it works for the design stage review. So the CPHD would submit all the documentation for the to the certifier. We would kind of just do a like review, kind of high level review to make sure everything is there. And then like, no, it's not there, then we'll ask for it and then they'll give it back to us. And then we'll do our check to make sure like, okay, and then we'll say like, is the criteria met or not? If it's not, then we'll issue a report kind of outlining the things that need to be addressed, and then the CPHC would take it and look at it again, and then resubmit it hopefully until the criteria is met, and then we would sometimes, yeah, we could issue also a design stage assurance letter, and that says basically that if the building is constructed as designed, then it will meet the passive house criteria. Yeah, like I think I already mentioned this before. Construction during the construction stage, this varies a lot. Sometimes people do site visits. If that's the case, like it's usually just a few at kind of key points, like the window install, maybe the blower door test, maybe during ventilation commissioning. Um, yeah, but other than that, if it's, if the consultant is competent, then yeah, we just um review site visit reports, answer questions, that kind of thing. Um, yes, this is just a point that is, oh, sorry, it's important for the team to notify the certifier of any change orders that may affect certification. So if it's a small thing, then the CPHD, of course, can just check, update the PHP. Okay, this is fine. But if there's any kind of questions about does this impact certification, that should be brought up. And then, yes, the post-construction assessment is the last piece. Again, we're really reliant on photogats and site visit reports. And then again, we would just kind of clear up any outstanding items that were not confirmed during the DSR. Um, and yeah, going through the airtightness testing and ventilation commissioning, and just reviewing any changes that happened during construction, which always tend to happen. But yeah, if there's any deviations from the design, the consultants would go in and update the PHP, and then we would just have to kind of double check all those updates. Okay, yeah, this is just a point. I think Andrew wrote these. Newbies fear newbies fear of this as certification and fear the process. Veterans think this as the easiest support. Yeah. So this is just to say, like, yeah, some people can like be scared about this last part, but actually if everything else has gone smoothly, if if there hasn't been any major changes, if there's been good communication, then this is really the easy part. It's just checking all the boxes. How am I doing? Oh, I'm not doing so great, am I? But this is a short part. Just a few tips and tricks that I thought of. One is the PHP check. So there's this tab, PHP, the check tab right after the verification tab, and I feel like people don't usually use this. I, th I think most people know that the first part is to check if there's any errors, and obviously if there's an error in your PHP, you'll fix it. Hopefully. Sometimes we get PHPs with like a bunch of errors, and then it's very frustrating. But there's also this plausibility check, and it's down here. Oftentimes it's hidden away, so you have to press this plus button to unhide it. But it's a good to go through all of those points, and it's just PHP is just automatically doing a sense check to say like, hey, like the areas, like it'll do a check and say like, hey, all the west areas and the east areas aren't the same. Like, is that right? Or like you have a really low like UG value for your glazing. Like, is that correct? So it's good to kind of also go through those plausibility checks and just say like, okay, yeah, yes, this is correct. It's because blah blah blah. And there's space to like make a little comment. Um, Plumbing sacks. Yeah, typically, yeah, in buildings you have these plumbing sacks that are vented towards the outdoors, and when they're open to the kind of sewage line below, there's a lot of convection loss actually that's happening, because air is just kind of traveling through these pipes. We often recommend, if possible, to put an AAV on the top air admittance valve on the top of the sack so that you're at least eliminating the convection losses. There'll still be a kind of point thermal bridge through the roof. But the convection losses are the big piece. Sometimes that's not possible because of the code and what they allow. So if that's not possible, then you should really like um, insulate this pipe, and you can test out the effect um, of this thermal bridge in your PHP kind of directly. Yeah, either way, you should at least insulate kind of here so you don't have, again, like condensation risk of mold growth issues. And now there's this new calculator. So on single family homes, it's usually just like one vent stack, and it's fairly easy to just use that tool that's in the PHP. But on these like bigger multifamily buildings, we have like this complicated network of pipes. PHI created this new tool to model this correctly because the kind of old way was too conservative. Yeah, so I'm not going to go into that, but use the tool. And if you don't know, if you don't have access to it, you can also talk to your certifier about it. Again, the FRSI issues, yeah, can sometimes be overlooked and not thought about. Yeah, you can use conservative estimates for psi values, but if you have a junction where you have a high um, thermal bridge psi value, then you should check for the FRSI. There's kind of no really getting around that. These are the minimum temperature factors for the different climate zones, but like I said before, you will also get your project specific one when you model it in PHP. 10. Yeah, this is just an example of a door install, modeling it and calculating the FRSI. Um, Ventilating all the rooms. This is also one that often gets missed, not so much in like single family house, but like for example, in this ventilation, yeah, we have supply in the bedroom and the kind of living room, exhaust in the kitchen, exhaust in the bathroom, and this study over here is not being ventilated at all. And there's no like room for cascade ventilation or anything like that. So like this is not this needs to be have a supply vent there. Also, you want to make sure that you're not short circuiting. So in this case, there's an extract in the kitchen and also a supply, which is kind of meant to, also ventilate this part of the space, but it's really not deep enough into the space because this is just going to short circuit and the supply is just going to get exhausted here. And like, is this space going to be, it's questionable if this space is going to be properly ventilated. So I would suggest that this be kind of brought in further into the living area. Um, if you're doing supply air cooling, so cooling through the ventilation air on the cooling load, sorry, yes, on the cooling load worksheet, there's a little kind of check where you can put in the minimum supply air temperature. So that's the kind of lowest temperature of your supply air. And then it'll do a little check to say like yes or no, basically it is possible to cool just through the ventilation air. Um, yeah, because in the cooling worksheet, on the cooling units worksheet, it may say that the system is okay, but you really have to check that you have enough kind of air to yeah, meet the load, which is on like the hottest day. Okay, yeah, and just in closing, yeah, engage your certifier as early as possible, ideally at the beginning of the project. Keep them abreast of any progress, timeline changes, important design construction changes, and don't make any assumptions without checking with the certifier. And if you have any doubts about anything like how to model something, what's an appropriate assumption, like is this meeting the criteria, like just ask. um and yeah, if there are construction changes that come up, yeah, vet them with your certifier.